Hey everyone, today we are diving into Unit 4 of AP Physics 1, Momentum. By the end of this video, you will understand what momentum is, how it's conserved, and how it helps explain everything from car crashes to colliding cars in a lab. Let's get started. First up, what is momentum? Momentum is basically a measure of how hard it is to stop something that is moving. The faster and more massive an object is, the more momentum it has. We define momentum P with the equation P equals mv, where P is momentum in kilograms meters per second, m is mass in kilograms, and v is velocity in meters per second. So if a 2 kilogram cart is moving at 3 meters per second, its momentum is 6 kilograms meters per second. For example, imagine a bowling ball and a soccer ball both rolling at the same speed. Even though their velocities are equal, the bowling ball has more momentum because it has more mass. Now, what if we change an object's momentum? That's where impulse comes in. Impulse is the change in momentum, and it's given by the equation impulse equals F times delta t, which equals delta p, where F is the force applied, delta t is the time the force acts, and delta p is the change in momentum. This explains why airbags help in car crashes. They increase the time of impact so the force is smaller, even if the change in momentum stays the same. Momentum is always conserved in closed systems. That means total momentum before equals total momentum after. Or, if 1 and 2 represent the two objects in a collision, m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. This applies to things like two cars colliding on a frictionless track. Even if they bounce off or stick together, their total momentum stays the same as long as there are no external forces that interfere. Now, here's a simple example. Imagine two ice skaters on a frictionless rink. One skater pushes the other. The first skater moves backwards and the second skater moves forward. Even though they go in opposite direction, the total momentum of the two skaters stay the same because there is no external force. When they push each other, that is an internal force, so momentum is conserved. There are two kinds of collisions in physics. Elastic collisions, which occur when objects bounce off each other and both momentum and kinetic energy are conserved. There is also inelastic collisions where objects bounce off each other and momentum is conserved, but kinetic energy is not. In perfectly inelastic collisions, objects stick together, momentum is conserved, and kinetic energy is not. Here is what the different types of collisions visually look like. Let's start with a simple question with a force time graph. We are asked to find the change in momentum, otherwise known as impulse. Feel free to pause and try this yourself before I answer. From the equation that we just learned, impulse equals force times time, which means that we should find the area under the graph, which is 35 kilograms meters per second. Okay, so now let's try another problem. We are tasked with finding the final velocity of the two astronauts. Take some time to try it by yourself before I give my explanation. Okay, so this is the answer. Momentum is always conserved. The equation for the conservation of momentum equals m1v1 plus m2v2 equals m1 plus m2 times the v total. There's only one velocity on the right since the two astronauts grab onto each other. Thus, they move together at the same velocity. Okay, so to set up the equation and using the values in the prompt, 70 kg times 15 meter per second plus 60 kg times negative 5 meters per second equals 70 kg plus 60 kg times the v, velocity. So velocity of the two astronauts is 5.77 meters per second. Now let's do our last problem today. So take some time to read. We are finding the velocity of the first car. Now, once you've tried it on your own, come back for the answers. Since the collision is completely inelastic, momentum is conserved, but energy is not. Furthermore, the two cars stick to each other and travel as one. The equation for conservation of momentum is as follows. Initial momentum equals final momentum. There are two initial masses with different velocities and one final mass with a single velocity. Therefore, we can write m1v1 plus m2v2 equals mv. Rearranging for final velocity, we get v equals m1v1 plus m2v2 times m. At this point, we can denote which direction is positive and which is negative. Since the car traveling west has more momentum, we will consider west to be positive. Substituting our values into the equation, we get v equals 400 times negative 20 plus 800 times 15 times 400 plus 800. Since this value is positive, the final answer is 3.33 meters per second west. To sum it up, momentum is mass times velocity. Impulse is force times time and changes momentum. In a closed system, momentum is always conserved. Collisions can be elastic or inelastic. Pay attention to whether kinetic energy is conserved as well. And that's it for Unit 4. Practice with collision problems, draw your system diagrams, and remember, momentum is always conserved. Visit vikinginitiative.com for more resources. If you have more questions, you can join the AP Physics 1 group chat and ask our tutors. Thanks for watching.